this now brings us to the end of today's lecture. So today was all about unsupervised learning, which differs to the approaches of supervised learning, which we discussed in previous lectures, in the way that now the data doesn't have any labels. We have unlabeled data and we are just looking for some structure there. And the two approaches which we looked at, two techniques from unsupervised learning, were first principal component analysis, or PCA, which is a way for performing some form of dimensional reduction, where I look for directions in the data where the data varies most, and I will basically choose dimensions by just adding them one by one in the kind of amount of variance they explain of the data. And this is a very popular technique which is used to reduce the dimensionality, and we've seen that it can be very useful as well if I have a high dimensional data and I just want to make a nice two-dimensional plot out of it. The best two dimensions to plot it on would be the direction of the first two principal components. The other technique we looked at was clustering, in particular K-means and hierarchical clustering, which is just a way of just from the data, just from the kind of distribution of points in the predictor space, find out whether there's some kind of grouping or clustering of the data, and whether I can see any structure of this type. And this can be quite useful if I want to see whether certain data points are similar to each other. Even if I do not know what they are, I can still see whether they are similar, like the example I mentioned regarding Amazon customers. Maybe Amazon doesn't know what type of customer I am, whether I'm a kind of academic, maybe some nerd, but at least they can see that I buy similar books as some other people, so I must be a somewhat similar customer. And I can use this information to say, come up with recommendation for me. Whenever someone else in my grouping buys something, then I can say recommend it to the other people. And even if I do not know what this group is about, I can still make recommendations for them. So this is a very powerful technique, and it can be used especially if I do not have labels here. I do not know what type of customer I am. I do not have a good model to predict whether I will like this book. All I can do is I can say I'm similar to other customers, and if they buy something, then it should probably be useful for me as well. So those are very powerful techniques, those techniques of unsupervised learning, especially if I lack labels, or if I want to look at those techniques, as I discussed earlier, of kind of semi-supervised learning, where maybe I have some labels, but not for all data points, and maybe I want to do some clustering first, and then I want to propagate labels within clusters to kind of enrich my data set to then perform some supervised learning afterwards. So often those techniques go hand in hand. For example, I can do principal component analysis, and then I can do a regression against the principal component. Maybe my data is so noisy that regressing it against all data, against all predictors would just be too noisy. But if I first do the principal component analysis, take say the top 10 PCAs and regress against those, then I will get a much better result. That's a very common technique in finance, and it's called principal component regression. And it's just kind of, it combines PCA with supervised learning, and it's sometimes you can really combine those techniques, so it's quite useful that you know about both of them. So, and as always in the tutorials you will see a bit more in practice and in detail how you can apply those techniques on real data sets, as well as some of the conceptual examples which we discussed earlier on in the lecture.